Hello and welcome to another video. In this video, we're going to be working on longest repeating character replacement. So in this problem, you're given a string S and an integer K, and you want to choose any character of the string and change it to any other uppercase English character. You can do this at most K times. Return the length of the longest substring containing the same letter that you can get after performing the above operations. So for example, if we have ABAB, and we have two replacements, we can either change the two B's to A's or the two A's to B's, and that would give us a valid string. So we can have this whole thing be a valid string. Now in the second example, we have A, B, A, B, B, A, and we have one change. So the change you're going to want to make is either going to be change this A to a B, and that's going to be a 4-length string, right? So if we change this to a B, that would be a 4 B's in a row. And we only have one change, so we're going to either want to do this one, or we can change this B to an A, right? Same thing. So this B to an A is going to be also a 4-length string. Okay. So let's just get some intuition for this problem, right? Like, how did we know, for example, in this, like let's say you have something like this, AAB, A, let's say you have like CC, and you have 3 swaps. So naturally, you think, like, right, in your mind, you think like, hey, what's going to be the cheapest? Well, it's going to be something like this to change these, because I have so many A's, right? And so you generally start thinking like, I have a lot of A's, so why would I change A's? It's usually better to change other letters. And that is part of the intuition you need for this problem. For example, if we're on this string, why would we change the character that happens the most, right? We need everything to be one character, so wouldn't it make sense to just take the character that occurs the most times? That makes sense to me, right? So if we, first of all, let's also think about like where we're going in this problem as well, right? So we have a substring. So we have substring. And so like I said in a bunch of other problems, if we have a contiguous substring, you want to try to do a sliding window. And then if you don't have a contiguous substring as a default, you want to do a DP. So here we do have a contiguous substring. So let's say we just have something like this. And let's just say, let's say k equals even 1, right? And try to go through this example. A, B, A, C, C. Okay, so like I said, if we're on this part of the string, we're just going to want to change. We're going to want to make as few changes as possible, right? So we can conserve our changes. So we're never going to want to change the biggest letter. That wouldn't make any sense, right? So we need to somehow store like what's the quantity of the biggest letter and then how many more changes we need to make. So for example, if we're on this part of the string, if we know we have 3 A's and that's our biggest letter, then we know we need to make one change, right? So that part is pretty straightforward. So the only thing you need to keep track of is what's the count of the biggest letter currently in like your subarray, and then you're going to try to change everything else because that's going to be the cheapest. You want everything to be one letter, so naturally you're going to want to change everything to be the biggest letter. But how do you keep track of the biggest letter, as you're going through these? It might change, right? Like, for example, if we have like CC, let's say, you might keep going, and then all of a sudden you have more C's. Well, how do you keep track? And then like all of a sudden you might have another letter and another letter and another letter. So a nice trick you can use is, because this is only big letters, right? This is A to Z. So because it's only A to Z, how many letters is that? That's only 26 letters. So we can actually just dynamically it doesn't cost us much to just get the count of the biggest letter. It's only 26, right? This is pretty much constant time. So in all these problems where you're given letters and all these letters can only be like A to Z or something, it doesn't cost you much to just maintain a dictionary, and you can actually do lookup. So you might think it's like n squared, but it's really just big O of n still, because this is only 26. And so now let's think about how we would approach this, right? So let's do the same problem. Let's say we have, something like A, B, A, then we have like C, 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 D, A, B, C or something. That's good enough. Okay, let's just like go through this problem and figure out what we're actually going to be doing. So we are going to maintain a hash map of the counts of letters, right? Like that part's pretty obvious. And we're going to have a result. So we're going to have a result. And we're going to have a hash map. Let's call that counts maybe. Okay. So our result's going to be 0. Our counts is going to have nothing. Let's use another color. And let's try to figure out what this is going to look like. Let's just say k equals, let's just say k equals 2 or something. Okay. So what we're going to do is we're going to maintain a count of each letter, and then we're going to always check for the biggest count and like how many changes we need to make. So let's see what that's going to look like, right? So let's start off over here. So we're going to take this A. So this A is now going to have a count of 1. Okay. Then our biggest letter is 1, and we only obviously when our string is less than or equal to k, we don't need to make any checks, right? So for this, these are both going to be valid without making any checks. So this is going to make a equals 2. Our result is going to be 2. And now let's take in a b. So now that we take in a b, we have a b count of 1. Okay. And so how many changes do we need to make here? So we're going to take our biggest count, which is 2, and then what's our length of the word, right? Our length of the word is 3. So if our length of the word is 3, how many changes do we need to make? It's going to be 3 minus 2. We need to make 1 change here. And so that's less than k. So this is a valid string. So let's change this to a 3 now. Okay, because that's totally fine. We can use that. Okay, so let's change this to a 3. All right. Now we're taking in another a. So let's change this to a 3. Okay. And now let's check again, right? So we have a 4 length word, and our biggest count is 3. And remember, we're gonna always just check for the biggest count by just getting the maximum value in this dictionary currently, and that's gonna give us our biggest count in O of 26 time, which is totally fine. So we have 4 minus 3. So now we have 1, and we can make 2 changes, so totally valid. Let's keep going. We're gonna add this C. Okay, now we have a C count of 1. Now what do we have, right? Like this is no longer good. So we have 5 letters, and our biggest count is 3. So we have 5 minus 3, and we have 2. So totally valid again. So I didn't update this, but this should have actually been updated to 4, and now it should be updated. And this should have been updated to 1 as well. So 4, and now we have 5 length because we're fine. Like we can make all these changes. Now let's go over here. Let's add this C. Okay, and for this C, now we have a C count of 2. So what do we need to actually be doing? Well, let's figure it out, right? So we have 6 letters, and our biggest count is 3. So we need to make 3 changes, but we only have 2. So now we need to be shrinking this. And so let's actually use another color for the shrinking. We need to be shrinking this to make it a valid string, right? Okay, well, let's figure out how far we need to shrink it. So let's get rid of this A. And so obviously, as we're getting rid of A's, we're going to have to keep shrinking, right? Because now we have 6 minus 2, so that actually hurt us. Now we need to make 4 changes, right? Which is, sorry, we don't need to make 4 changes because this is length 5. We need to make 3 changes. So it's still going to be the same. Okay, yeah, we need to make 3 changes. And you can see that, this, like, if this is your string, you need to make 3 changes, right? You either need to change, like, 2 A's into C's and a B into C, or 2 C's into A's, or whatever you want to do, but it's 3 changes. Okay, so we need to remove more. So let's remove this A. Now the count is 1 here. And notice now our biggest letter is C, but we don't really care. We just need the biggest count. So now we have 4 letters, and the biggest count is 2. So now we have 2 changes we need to make. And now you can see that in this BACC string, that's a valid string now, right? So we're good again. But that's not more than the result. So now we can keep adding to the string. So let's do that. So let's add a C. Now our count of C is 3, right? And so now that our count of C is 3, we need to check again, like, do we have a valid string? So we have a string of length 5, biggest count is 3. So we need to make 2 changes, so we do a valid string. Okay, perfect. Now let's add this D. And when we add the D, we have, so notice we don't even really care about what characters we add. We just care about what character we have the biggest of, but we can't do that in big O of one time. So that's why we have this hash map. Okay, so now we have 6 characters. So let's just clean up some of this stuff. We don't need all this and all this. Okay, there we go, way more space. So we have a 6 character string. So 6. And how many, what's our biggest character? It's actually 3. Right? So we need 3 changes. So now we need to start deleting again because the string is invalid. So we're going to delete this B. Bye-bye to the B. B count is going to be 0. Okay. Now we have 5 characters, right? So if we have 5 characters and we have 3 C's, we have 2 changes we need to make. So now we're once again at a valid string. Perfect. That's what we wanted. Okay. Now let's add this A. And so now this will be a 2. Now we're at a string of 6 again. So we're at a string of 6. Our biggest count is 3. We need to make 3 changes. So now our string is invalid again. And so let's actually get rid of another character. So we're actually going to get rid of this A here. Okay, and so now this count is going to go back to 1. And then now we have a valid string again, right? Like this is a valid string. We can make 2 changes and make it all C's. Okay, so now let's go over here. Let's add this B. Now we're at a string of 6 again. And we have our biggest character is 3. So 6 minus 3. Pretty straightforward, right? Okay. Kind of annoying there. Okay. There we go. Okay. So we have 3 characters left. So this is an invalid string once again, right? So yeah, this is an invalid string once again, so we need to start removing stuff. So let's remove this C. So now the count of C is 2. And so now we have a string of length 5. The biggest character is 2, so we have 5 minus 2, right? 5 minus 2, it's going to be 3. We only have 2 changes we can make, so we need to remove some more. Let's remove this C. Now the count is 1. Now, obviously, this isn't going to work again, right? So we're going to have 4 letters. The biggest count is 1. We need to make 3 changes. So let's remove this C. Now the count of C is 0. Okay. Now we have a string of length 3. So we have DAB, and the biggest count is 1. So now we do have a valid string. So 3 minus 1 equals 2. So now we do have a valid string, right? But none of these is still bigger than the result. So then we need to add this C. The count would be 1. And then what's the biggest character? 1. And we finally have, so let's think about this, right? So we have a 4 length string, and the biggest count is 1. So we need to make 3 changes. So we need to get rid of a letter. So we need to chop off this letter, make this count 0. And now finally we have a valid string with 3 characters, and the biggest count is 1. So that's going to be 2. And so our result here was 5, which is, I think it's either like something like this or something like this would all work, right? Yeah. You want, or something like this even would work. So any one of these is like our best string. But now you can kind of see how this goes. All you need is to count the biggest character, and because there are only 26 characters, we can just use a hash map and call it every single time. You can make some optimizations where you save the biggest letter and you don't call the hash map, but it's not going to save you any time, right? So instead of 26, on average, you're not going to call the hash map every single time. You might call the hash map like whatever, third of the time, 10th of the time, whatever you wanted. Okay, so now let's actually go through the, like we have enough to code up the problem, so let's do that. So where do we start? So we need to make a hash map, right? So we can just say like letter counts or something equals. Okay, we're going to make a left and we're going to make a res. We're going to make them both equal to 0. And we're going to use our sliding window here, right? So we can say for right in range length of the string. So what do we need to do at first? We need to add a little letter. So letter counts. All right, let's just make it counts, right? Less words. Okay, so counts SR plus equals 1. We're going to need to add that letter. Now, what do we need to actually do? So we need to actually get a max letter count here. So we can just say like max count or something equals max of counts.values, because we're going to want to get the biggest value in the dictionary. And then we can just say something like while k is less than, and so what, like how many letters do we have to change? So it's going to be the length of the whole string, which is right minus left plus 1, right? That's the length of the whole string. And then how many letters do we need to change? It's going to be the length of the whole string minus max count. That's how many letters we have left to change. So if we have more letters to change than k, then we have to make the string shorter. So we're going to say, we're going to put this in a while loop, and we're going to make the string shorter. And how do we make the string shorter? We need to remove from the left, right? So it's going to be counts SL minus equals 1, left plus equals 1, and then we need to get a new max count, essentially. So you can probably even throw this in here instead, because, yeah, you don't need the variable if you wanted to, but this is fine doing it this way too, so you can just copy paste this line in here. Okay. And so this is going to ensure that we have a valid substring, right? As in most of my templates for a two-pointer or sliding window. And so for a sliding window, you want to ensure that your string is valid, or your, whatever, your array is valid. So now it is valid. So now we can just try to maximize the length of it. So we can just say result equals max of result, and right minus left plus 1 is the length of the sliding window. Now finally we can return the result. And we don't need to update the right, because the right is actually going to be looping through the loop. It's going to be looping through the length of the string here, so we don't need to update it. So let's see what happens here. Okay, so you can see it's pretty efficient. And let's actually think of the time and space here. So for the time, it's going to be O of n, because it's the sliding window, right? Pretty straightforward. And for the space, so it's really, like I said, for the time, really it's going to be 26n, because we are calling this like values every single time, but 26n rounds down to O of n, which is why I said it's a lot easier when you only have 26 letters. Like if you had, if they said like you can use any ASCII value from like 1 to 1,000 or something, that would be there. You'd want to make optimizations, but for this, it's not necessary. Okay, and so for the space, we have 26 letters. So that's also O of 1, right? You can argue it's only 26 letters max, no matter how big the word is. And yeah, we don't have anything else safe. We just have this counts hash map, which is just 26 letters and their counts. So yeah, that's going to be it for this problem. Hopefully you liked it. Hopefully you did learn that when you do have these letters, you want to use the counts dictionary, and it doesn't cost you anything. So it's a very useful technique to use. And yeah, if you did like the video, please like it, and please subscribe to the channel, and I'll see you in the next one. Thanks for watching.